For monotile project that was to tackle a or must postpone articulate to demonstrate sorting using color. Root job, industrial automation, they streamline manufacturing, and then further study my integrate IIoT connectivity to that and cloud-based modeling. And take that data and then publish that to a dashboard. So, but so data dealing. The low and then do data and like to do it. So explain us, start from the ground up. We have our manufacturing scene here with entry conveyor and then an exit conveyor that has sorting belts here that each directs the air lamp. So we have three different colors in this scene. If I go ahead and start this, the idea is that when the box is going to go under this gateway here, the vision sensor will pick it up and that will determine the color of the box and then divert that to the appropriate exit ramp. So see it trigger the blue box there, went down the first ramp. There's a lane change here, it'll get down the second. And this is done through CCW ladder logic using timers. So when it sees that, it knows it needs to wait about 5 seconds for that metal box. And then once it is scanned, it'll be diverted down into that. So we're keep this going and jump over to CCW, explain a lot about how this logic works. This is only done in 7 lines of code. This first line is just looking at whether the system is active, and if that system is active, let's tell it, let's tell an expert risk here, let that running. And then you have 4 lines, but it's really just 2 lines that repeat over 3 times because we like those colors. But this is done using timers, and although there's 3 colors, it's actually in the scene is 9 different pieces, which was a cap, a base, and then a body for each color. So the vision sensor in the scene is can't read a Boolean text, trying to editor. So the first line of code here is checking for a blue piece, which is an integer value of 1 to 3. So it checks if it's greater than 1, and then it checks if it's less than or equal to 3. And it's that if those both conditions are met, then it knows a blue equals 30. So it allows power to route through here, and this does 2 things. It tells the system to latch on a Boolean tag, which in the PLC marks that there is a blue block curling the system, and then it also tallies up the counter, which is the information we all worry about. So as long as that Boolean system tag can jump to the next line here, that starts the timer that is connected to the sorter arm and the belts. So these timers are different for each color, but for the blue it's the closest. It waits half a second on-off timer, and then once half seconds is met, it's going to turn on the output for a full second, which will extend that arm and then run the conveyor for that blue block down, and that also latches off that Boolean system. So this is really important, but we really want to have this information more easily accessible. So I've tied 4 different values to Modbus registers. That first one, the very first Boolean, is the system status, whether it is running or not, and then the 3 next are just those counters for the blue thing and then the metal piece. But to read those, got this handy Python script. I'm going to run this just to get the ball rolling. And what this script does, a couple things. It's going to establish connection to the PLC over the network. Use the IP address listed right here. Going to connect to an MQTT broker in the same exact way with the IP address. And then also to a cloud-based Postgres database, or it's going to be, that's the angle where we want to put that information in the database. So the first step in this information exchange is going to grab, because it's connecting PLC, it's going to grab those 4 Modbus registers that I talked about. And once it has those, it's going to deposit it into our HTTP browser. So we can look at that here. I have my name, we got my color data, and then over here we can see every time a value is pulled, just picked up a metal. So it went from counter 10 to 11. And then finally, the same trick is creating a table inside that database, and then from the same values it's publishing to the FTP broker is also subscribing that database to those values, and then every second it is updating and inserting a new row into that table with the ID of PLC, the time, the system status, which running and not running, and then the integer value of those 3 colors. The final step here is we want to be able to visualize this in an effective way. So another script that is running this Streamline dashboard. And if you can jump over to the dashboard here, I'm going to just refresh this. All right. You have my name on top, and we have this large pilot light that indicates our system is running. We both see here the manufacturer of our reactor is running. All this data in this table was pulled directly from that Postgres cloud-based database, that cloud database. We can see that initially when we pulled it, the system was not running, and then at about 60,895 seconds, we put that system back on. We can see it started counting and picking up all those values. So if we were to go back in and then stop the process and then jump back to that dashboard, make sure it's refreshed, it will pick up that system is stopped. And then vice versa, we go and make sure that system is running, refresh it again. The system is running, and we can jump down and we can see exactly when that break in that system happened. So we know exactly that was 23 seconds into 30 seconds. So for 10 seconds, that system is down with that information. And this is also displayed very visually inside a table. So we have these three values: blue counter, there's colors a little whack, but we have a blue, we have a green, and then a metal. And you can see as these are counting up, and then this is right here is when we started, deactivated that Python script to start pulling the data. And then we also at the top here, we have a method of clearing that database. So if I go and clear that, it's going to tell us our database is cleared. If I refresh it, it's going to pick up new data. And then maybe in the event that our system is no longer running, or maybe we'd have our polling has stopped. The data again, it'll alert the operator that data is not available yet, and we're still waiting to publish the value. So I think this whole process demonstrates a great standard of information, everything from the factory floor all the way up into very viewable and quantifiable data easily available to a dashboard, an operator or technician, whoever might need it.